Good morning and good afternoon, everyone, and welcome to that webinar. My name is Marie-Line Vaiani. I'm the Secretary General of the World Energy Council France and the French member, which is the first member committee of the World Energy Council. And I also have the honor of chairing the Energy Committee of the World Federation of Engineering Organization, WFEO, which is hosting this webinar today. For those of you who may not be yet familiar with WFEO, the World Federation of Engineering Organization is a global non-governmental organization that represents the engineering profession worldwide. Chloe, maybe if you can skip the slide. Established under the auspices of UNESCO, it brings together a network of 30 million engineers across more than 100 countries, and with them a large and valuable pool of expertise. WFEO operates through 13 specialized committees and working groups. And what are we doing in the specific field of the SDG 7, Sustainable Development Goal 7, which is a clean and affordable energy for all? As energy engineers and scientists, we all share a responsibility for identifying and implementing the most effective technologies for sustainable development. And as chair of the Energy Committee, I strongly believe that international cooperation and sharing of knowledge, including best practices, efficient energy policies, and technological innovation, are key and essential to achieve SDG 7. This is the guiding principle of our work within the Energy Committee. Among our diverse initiatives, we have launched in 2025 a webinar series, which has started with, maybe Chloe, if you can switch, the electrification access, next one, access gap and policies recommendation to address it with the Professor Abubakar Sambo, which was chair of the electrical task group of WFEO. Then we have shift to understand why nuclear power is making a comeback with Dr. Henri Payer from the International Atomic Energy Agency. And it is our pleasure today to shift to another very important dimension of the energy transition, and sometimes not enough covered, why PV module recycling is a necessity for future PV development. The webinar we are organizing today shall make clear the importance of PV module recycling as a necessity. And for that, four experts from different regions of the world will give their views about the actual situation of PV module recycling. And at the beginning, it is my very great pleasure to give the floor to Carsten Ahrens, which is currently chair of the Solar Task Group, and who will give you an overview of PV recycling, and who has also made a very important one preparing that webinar with all the different members of his task group on solar PV. So please, Carsten, it's my pleasure to give you the floor.
Yeah, thank you very much, Marie-Line. I'm very pleased, and thank you for this welcome for me and the other panelists and the colleagues from far away who have registered to participate in this webinar. I'm now open the screen. Modular recycling, a necessity for future PV development. This is the title, as you mentioned, and this may be the first step towards a photovoltaic circular economy. I doubt it a little bit, but it is necessary to start with it. So what's the time you gave it? And I want to give a warm welcome to the panelists from 4 regions of the world to cover all possible views about solar energy, especially photovoltaic energy. This is me, Florian Hase. We are from Germany. Australia is here with Adrian, Piani, and his colleague, James Petesic from PV Industries. South Africa, Ismail, Jefferies come together with Steffen Schroder, and hopefully Yogi Goswami from the United States will also be with us. The minutes you can see are minutes we have to think about and have to follow these. The background for this webinar, of course, has to be described a little bit. We talk about the development of photovoltaic, its installations and yearly additions. We see that photovoltaic is the largest power capacity now and also the cheapest one. Maybe nuclear, which is another thing we talked earlier in another webinar. The future amount of PV waste and the end-of-life modules has to bother us, and it does it because it has such an amount of material which cannot only use to fill land in the normal way, because the material content of photovoltaic modules is that precious that we cannot throw it away only, and the recycled materials in addition can be used for new photovoltaic modules. In the EU, circular economy is a big topic, and even photovoltaic development is included in this hope to come up with circular economy. We all have to follow national obligations. We all in our countries have recycling activities, and we all have to see that there is a need for industrial recycling, which comes up with enough money to make it interesting for companies. The cumulative power capacity I talked about is got a very surprising development. You can see 68 years it needed from the first silicon solar cell till today, or let's say till 2022, to come, it's too early, to come up with about 1 terawatt capacity. And only within 2 years, we are now here, we have 2.2, and maybe in 2025, it is even more, to double it. This is a fantastic development, really impressive. But of course, it also gives some problems with the end of life point of view. But just to make it clear again, all estimations about development of photovoltaic are much, much below the actual development, which is green here. And even the respective associations like WFEO are always below the development. They forecasted it differently and much lower. What is the amount of PV waste? I use this from my colleagues from solar materials. You can see we are now here. We have worldwide an amount of about 250,000 tons of recycling volume, and the contained raw materials value is about 100 million euro. This is just for the years from 2022 till 2035. If you see the whole development, you wouldn't see what we talked about here, which is this picture, but then you can see that it is estimated that we come up in 2050 with a volume of waste in megatons, 2012 megatons. And if you underestimated as WFEO did it before, and then it could be much more. And if you see that with the amount in tons, you also see billions of material value, then you come up with volumes with worth, which you cannot neglect only. Looking at the development at the EU, one of the 4 regions, we are here with about 350 gigawatt installed capacity, and it is expected that it is 750 in 5 years. The solar market in Australia is not that strong, but 38 gigawatt are nowadays the number, and you see also a very steep increase. South Africa is at the beginning, but still reached 3 gigawatt installed capacity with an amount of about 450 projects. The United States are like Europe on a rather high level, 220 gigawatt are installed, but the most of it are within utility plants, I would say, where you harvest the solar. The second part is the residential part, which uses the photovoltaic on roofs, for example. If you have a look on all renewable capacity additions in 2025, you realize that solar is by far the biggest one. More than 80% of all renewable capacity additions are due to solar. Wind is the next portion, and all the other three can be nearly neglected. If you calculate it or compare it with other technologies, you can see coal and natural gas, the curves, the lines are going down, the slope is decreasing, whereas wind and solar is increasing. Solar is the strongest increasing power, and this or the next year, it will reach the coal line and then will become the biggest share of cumulative power capacity compared with all the others. So it is very important to see and think about the necessity for recycling. Just in Germany today, we talk about 60,000 tons of used photovoltaic modules, which reach the end of their lives, and many will be disposed, likely also by landfill methods. But in 2030, a quantity of 1 million tons is expected. Then it's not longer possible to fill the land by this. So just Germany. So you can imagine worldwide, it is a multitude of this number. And these numbers have to be reinstalled. And in addition, a multifold has to be added to reach the net zero goals. But still, existing shortage of rare elements becomes a real problematic bottleneck in the development and could really stop further increase of photovoltaic electricity. So there is a need not only to recycle, but to install a circular PV economy. Germany hopefully could become the first country to do it on an industrial basis. This is what I hope for all of us. The achievements which we have with photovoltaic, you, Marie-Line, talked about the goal of clean energy and affordable for all people in the world. There's another goal, number 12, and this is what we also have to look for, doing more and better with less, not throwing away what we used for a long time, all the material which we used in photovoltaic modules. We have to look for recycle them and possibly reuse them in a way which makes it also interesting for companies which are involved in recycling processes. The circular economy, as I told you, is a big part of the objectives within the European EU, in the EU, and in March 2019, the adopted comprehensive report on implementation of circular economy also included photovoltaics. In Germany, we have at least two companies, Fraunhofer Center for Silicon Photovoltaics, together with Reiling and Solar Materials. These both started to recycle in an industrial scale, and one of the results is these PERC solar cells, which are made from 100% recycled silicon and reach an efficiency of 19.7%, which is very good. And Solar Materials, our next speaker, Florian, as a representative of Solar Materials, is another very thrilling startup company with facilities in Germany and, as he will tell us, soon also in Italy. So it is a real European outlook for us. And this is the outlook which we need. The outlook and the facet of this outlook should sound industrial recycling of PV modules, which is interesting not only for companies, these two which I talked about here in Germany, but there are still some barriers in all countries. For example, a survey in the US policies and initiatives, the NREL, identified several barriers. For example, there are data gaps about the amount of photovoltaic modules and the end of lifetime. They talk about inadequate recycling technologies, and also this recycling is always connected with 100%, but the share is much lower very often. There's no infrastructure to collect these photovoltaics. There are regulatory uncertainties. When is reached a photovoltaic module, its end of life, couldn't it be used longer, and so on. So my end, PV electricity in a circular economy. This is a need for the energy future. Thank you for listening.
Thank you, Carsten. And now maybe we can give the floor to the next speaker of this webinar, which is, if I don't made any mistake, Professor Jean-Philippe May.
Yes, it's me, Florian. I'm here in behalf of Jan Philipp, CEO of Solar Materials. And yeah, it's a great pleasure to present you our solution, how to deal with the very strong increasing amount of end-of-life solar panels. For this, we will present you our solution for our recycling technology based in Magdeburg, Germany. We invented a technology what allows us to recover all, including materials, including the high valuable materials, silver and silicon. Yeah, for this we started in April this year with our industrial recycling line in Magdeburg, with the capacity of 7,000 tons per year, which was about 350,000 modules per year. And with this technology, we are using a reverse production process. So we remove every materials layer by layer. So remove the glass section on the top, removing the very strong and difficult to handle a fraction of the EVA film, and to get to the most valuable and the core of the solar cell, the silicon and the silver part, and then to remove also the backside of also a plastic part. As you already saw at Carsten's presentation, the very strong increasing market of the PV modules you can see here in 2030. We expect amount of about 1 million tons of solar panels, end-of-life solar panels worldwide. So this is a very increasing market where it's necessary to come up with new recycling technologies and new recycling lines to recover all these materials back. We have identified 3 different types of end-of-life structure. This is the normal or typical end-of-life, the technical end-of-life, what's about 25 to 30 years when it's the real end-of-life of the solar panels. But then we also see the very early loss of the modules with about 10 to 12 or maybe 15 years with some production errors. There are some modules with some defects on maybe the back sheet or also on the EVA foil. So that creates a delamination effect and also gets the modules back to us a lot of earlier than the normal technical end of life. And also at the third part, we have some modules from weather defects like storm. With our recycling technology, we have the possibility to get all materials back, also the silicon and the silver. Both are critical raw materials with an actual recycling and recovery rate of 0%. So there's a very high amount to get these materials back and get to new recycling technologies. About 10% of the annual silver production is used for the solar recycling technology, for the solar industry. So it's also very important to get this material back and to close the circular economy there. That's also very important for the economical part, because silver is about 50% of the value of the solar modules, even if it's only a very small amount of the weight percentage of the solar panels, but together with the aluminum, it's getting all this as a profitable recycling technology. To get to all these layers, we invented a thermal mechanical reproduction process. So we remove it layer by layer, and instead of pure mechanical like screddering technologies, or instead of chemical recycling strategies, we have a very economical and also ecological setup, that's very highly profitable and very easy to scale up. That's also the plan for our next years. So to get the important way, we start at our recycling process to remove the junction boxes and the cables to get to the copper and the plastics inside these cables. Then we remove the aluminum frame. These are all both standard processes, but then we come to our core patent to remove all layers, layer by layer, with our delamination process, and to recover also the silver from the silicon fraction, to get here separated silver and silicon material, both for the refining and also to get it back for the circular economy. Now we are having the capacity of our first line with about 350,000 modules per year. We are planning to get a second line next to it here in Magdeburg, Germany, and also to increase our recycling capacity towards Europe in the next year. For the recycling materials, we start here with the aluminum. It's a very valuable raw material, but this is a very common recycling strategy, so very easy for us to get this material back. Also the copper, the glass, we get a very high pure quality glass, so this we can use as a packaging glass. The plastic, it's going now for a thermal variation, but later on we plan also to recover the plastic section. And yeah, our core element is to recover the silicon and the silver, both very critical raw materials, and with a very high valuable, the silicon we use, for example, as an alloying element, or also to get back to the silicon industry or to the battery industry. And the silver can also return back to the circular economy and as a second life material. For this, it's very important to recover all materials, very strong increasing amount of solar panels. So for us, we are planning to expect our recycling capacity towards Europe, first to build up more recycling lines in Germany, and also next year we plan to build our first recycling line in Italy to increase our recycling capacity to 35,000 tons up to end of next year. So thanks so much. That's from my side, the recycling strategy in Europe, especially for Germany.
Thank you very much for your presentation. This shows that there are concrete solution, operational solution already available in different parts of the world, and this is very important. And this is also one of the topics, the purpose of World Federation of Engineering Organization, in showing that also some innovative solution already exist to the different issues we have to face. We have also, like you have seen, choose to make a mix of academic presentation and also industry presentation, exactly to show that that kind of mix of solutions and giving the big pictures. Just a comment, you can put your question in the chat. We will answer it at the end, or during at the end of each presentation, or at the end of the global presentation, to let the time to every speaker to show the presentation is prepared. There is still already one question. I think it's for you. Florian. She's about our recycling methodology effective for all brands and model of PV panels. So it may be also for Carsten. So I don't know which of you would like to answer to that question from one of our members of the WFEO Committee on Energy, Carsten or Florian. The floor is yours.
Maybe I didn't get the question quite clear. I would like to answer any question.
Okay, I think I got it. So for us, it's a lot of easier to focus on one type of PV modules and also one exact model, because we have to set up all the recycling line to the dimensions of the solar panels. So for us, it's not so easy to switch through different types and also very different technologies. That would be very difficult. So that's easier for us. So we focus especially on bigger amounts of the same type for example, from bigger solar parks.
Yeah, Adrian also tackled this problem. And concerning the circular economy, it would be very helpful to have a specific type of photovoltaic panels, same length, same thickness, and so on. So you can pack it in a better way, and you can handle it in your streets of recycling processes in a better way. Yes.
So thank you for the answers. And now we can skip to the next presentation, which is from about PV recycling in South Africa. And I think there will be Ismail Jefferies, a speaker, and maybe another one. So please, I give you the floor to show how PV recycling is organized, is done in South Africa.
Thank you very much. If you can just confirm that you can see my screen.
Yes, perfectly.
Thank you. So yes, I'm Ismail Jefferies. I'm from South Africa, specifically in Cape Town. I represent a municipality within the city of Cape Town area. Yeah, so we basically within the municipality responsible for the registration and installation and technical requirements for the installation of PV panels within the municipality. And we've also obviously seen a big increase in the PV uptake within South Africa. For the last few years, most probably not for the reasons it should be in terms of environmental friendly and trying to reduce obviously your energy consumption, but because of our ESCOM, the utility department, struggling with our total capacity within South Africa, and then having load shedding. And as a result, we've had huge spikes within South Africa in people installing PV panels. And since 2023, towards the end of 23, we've now, the utility have managed to basically restore the capacity power and make the fleets available, and the maintenance issues, etc., have all been resolved. And so far for the whole of 2025, we did not have any load shedding except maybe one or two, which we don't even noticed. So yes, in terms of the capacity, as Prof. Carstens also indicated, South Africa is still in the infant stages. And at least the National Energy Regulator of South Africa have amended the Electricity Act, where the requirement for licensing of these installations for facilities have been sort of amended and not required. And as a result, we've seen obviously a good uptake in all these facilities and installations. So far, yes, the numbers was probably still very low compared to the rest of the world. We're now sitting at 2.3 gigawatt. And the estimated moving forward in the next 5 years will most probably exceed the 10 gigawatt figure. And in terms of the number of panels, obviously here we're just looking at your smaller type of PV installations for residential and for commercial and industrial, which is your 400 watt and 500 watt modules. And these are the numbers we're looking obviously at in terms of the modules that will reach the end of life soon or within its time. And obviously the numbers are quite staggering. In terms of legislation, we do have legislation in place in terms of recycling. We've got the Waste Act, the classification of the Waste Act. Now, more important, this one in terms of the e-waste landfill ban that we have, where we obviously do not allow any electronic waste onto the normal landfill sites.
Sorry, Ismail, I think that the slides are not changing. We seems to remain on the first one.
Okay.
I think now we do not the slide at all.
You see now?
Yes.
Just need to get this.
Yeah, okay.
You can still see it?
Yes, we can still.
It's okay.
Yeah, so in terms of the legislation, we do have legislation in place that obviously encourage also the recycling of these modules. And then I'm not mentioning a lot of the challenges because I will leave that to our next speaker from South Africa. But from our side, obviously, we need to create a viable market to be able to recover the materials. And then I think there's also a need from the public awareness, raising the public awareness about the importance and the responsibility of the disposal for these modules, which is crucial to the success of recycling initiatives. So at least there are currently a lot of recycling companies also within South Africa. And here I will give it over to our next South African speaker, Steffen Schroder, who will be basically give us a rundown of what is being done in terms of the recycling of the panels. Thank you.
Ismail, could you please show the second and the third slide again? We haven't seen that. I think it's interesting.
I will try and display again. Can you see the screen now?
Yes.
But just click on the second slide and then afterwards the third one. The second one. Yeah, that's great.
Yeah, okay. So this one is basically a distribution of the installations per province within South Africa. So all these ones in C downstairs, for example, the Northern Cape, in the Northwest, Free State, Western Cape Province, Limpopo, Eastern Cape, Mpumalanga, Gauteng, and KwaZulu-Natal. So they represent the various provinces, the 9 provinces within South Africa, and that is the distribution within each province.
The third one, please, Ismail.
So this one is been work that has been done by Green Cape, one of the NGOs within South Africa, looking at also the PV recycling. And these are what they have gathered based on the installed panels, the annual number of end of life for that period of 2024 up to 42 in terms of the number of modules that we will be looking at.
Thank you, Ismail. I think that the end of your presentation on South Africa now.
Yeah, so
I
I'm
do
done
not
on
see
the
any.
technical side. Then Steffen will now take over from the recycling company for South Africa.
Okay, great. So we wait for him to connect.
Wonderful. Good afternoon. I hope everybody can see my screen. You can hear me?
Yes.
So thank you so much, Ismail, for showing everything that has happened. It's a pleasure to introduce you to Reclite SA. As Ismail mentioned, we are an electronic waste recycling company based here in South Africa. We've been in existence since 2009. We started out as a lighting lamp recycler, and we very soon realized that there's a lot more need for other types of recycling within the industry. That's where we started working in 2018-19 already on solutions for solar PV module recycling, focusing mainly on the recovery of aluminium, copper, the glass portions. And we developed our own technology where we are now sitting at 95% recovery rate of the solar PV module. There were a lot of other people in today that spoke a little bit about the history. So whenever I speak about PV recycling in South Africa, I always like to draw onto the fact that PV module technology is actually quite old. And it's really nice what Carsten said in the beginning, that how long it took for the first terawatt to be installed, and then how quickly we're growing. So we've really come a long way, and there's a lot more happening within the industry, obviously. And one of the big things is there's not just silicon-based solar panels that we've talked about now. Within South Africa, we also have thin film panels, and we actually have quite a few thin film panels, thin film type of technology, so CIGS panels being installed, and also a very large plant with cadmium telluride panels still in operation now. And so our recycling solutions are not just focused on silicon-based solar modules, but on all three different types of PV modules. So we're looking at the recycling of, we have a specific line for silicon-based module recycling, thin film type recycling, and also the effective recycling and recovery of cadmium telluride panels. And within the cadmium telluride panels, we are working on recovering cadmium telluride as an active material for trading, so that it can go back into the manufacturing part again. So why is this important? Well, so we spoke obviously a lot about silicon panels, and we recognize the need, and we spoke earlier about the fact that silicon panels need to be recycled for its rare earth minerals or silver. I've been in a lot of conferences and discussions where we spoke about the need for recycling and the need to recover the silicon and silver, which we are in the process of doing. So we are capable of recovering the silver, and we're busy improving our technology to increase the purity of the silicon that we're recovering. Why is this important? Because silver accounts for the PV module production market accounts for 20% of the entire silver production worldwide. What that means is if we want to have a sustainable development and continue driving PV installations, it is vital that the silver and the metallic silicon is recovered and goes back into the production. It'll help us decrease costs and ensure sustainability long term within the market. And we believe that as a recycler, it is an opportunity for us, but it's also a responsibility for us to continue to valorize the fractions that we're recovering, and bringing them back into the circular economy. Now, how do we do that? Well, we spoke about earlier, Ismail spoke about this. There's a legal background within South Africa. So we have the constitution that everybody has a right to a clean environment. We have a Waste Management Act that banned all hazardous waste from landfill. So silicon or any type of PV modules, any type of electronic waste is not allowed in landfill. Unfortunately, you know, what is legislated and what happens is two different parts. So we also have another more recent legislation, which is the EPR legislation, extended producer legislation, whereby OEMs are becoming liable for this. Because one of the things that a lot of people here are not talking about, and which is important, is that historically and even now, the recycling of PV modules is a cost intensive procedure where we're very struggling as recyclers to make this a cash positive and a positive contributing part. It actually costs more money to recycle the panels and to recover these fractions than what we can gather out in the back end. So the entire value chain, unfortunately, always requires something that we call a gate fee. I'm sure everybody's very much familiar with that. This is just a little bit of a background of what this means, the EPR regulations, and what it covers. It covers all EE, lighting, and paper and packaging. It was implemented in 2021. And in essence, any type of material, if everybody was compliant, which there's still a compliance uptake, from 2022, January 2022, in the future, any products that were coming in would have been covered under this EPR regulations, meaning that the recycling, paying for recycling, the any gate fees that are there, any transport costs would be covered by that regulations and by the OEMs. The good news is because this is in place, it also allows for, this is now a PRO that's specialized that we're working with in South Africa. And they actually have a very positive in driving that forward, where anybody can go on, request collections for the electronic waste and the PV modules. And it is still a forth and back. So the challenge here is some OEMs are not compliant, so they can't be covered by the system, but the OEMs that are compliant, obviously the end user has a competitive advantage there because there's no further cost to them. It's easy for them to manage their PV modules and other associated electronic waste at end of life. Again, here we're coming into where we're sitting with the PV module recycling and unfortunately our main driver. So when we first started out in 2018 and the costs that were associated with the gate fee to where we are now, we're looking at only about 20% of our original costs that we had is what we're currently charging as a gate fee. All of our developments that we've had, and I'll go into that just now, are all driven in valorization of component parts, localization as much as possible, but we're also not blind to the fact that we're living in a global world. So obviously, wherever we can, we are utilizing that in order to increase the value of our products that we're manufacturing. And this is the other part of it. So just a quick overview. We've seen very detailed description about technological solutions. We're using predominantly a mechanical system for the recycling and the recovery of our cells. We've been able to lean very heavily on the existence of a very, very good mining infrastructure and mining companies and mining technologies. And that has allowed us to build our equipment to mechanically recover 95% of the panel, and only for the last 5% of the important materials, that is going then through a chemical process in order to recover our metallic silicon and sulfur. Now, I spoke about earlier the fact that there's different types of panels in the market, and as part of us communicating with various different stakeholders, we've created these charts that we're bringing out there. How much of a PV module is actually recoverable and how much of it can be recycled. The reason why we're putting those two factors in there is a lot of people, and why we're measuring these two indicators is because we pride ourselves as being a company that is a waste to product company. That means a lot of recyclers recover a product sell a raw material, and then somebody else makes something else out of that. We are following the WLABEX and Senelec standards, and we're going not just level 1 recycling, but we're going 2 levels down, which means we recycle a product. We recycle the PV module. We create aluminium, copper, silicon, metallic silicon, silver, the silver batch. Then we have a second manufacturing. So we provide this to either another second company of ours, so another one of our offshoot companies that manufactures products out of that, such as in our glass, or other partner companies. And then we actually trace where these products go. And we also identify their production efficiency. Because when we're looking at this circular economy that we're talking about, we need to understand that it's not just, and we want to closing these loops, it's not just our efficiencies, it's the product that we manufacture. How easy is it for the next person to make a product out of that, and what is their waste percentage? Because any manufacturing process has waste. So our goal is that we are looking at least 2 tiers down, and our recycling and our efficiency rates are based on those 2 tiers, which is very important. I believe in the long term, where we're looking at these high tonnages, right now we've only been recycling now 5,600 tons last year of PV modules between the different chemistries. But when we're adding a 0 at the end, 1 or 2% extra wastage becomes significant volumes that need to be addressed, not just in our tier, but in the next step too. So that's where we're coming in. And this is obviously, sorry, I was a bit late with this slide. Everybody hopefully knows the Ellen MacArthur butterfly diagram, only using one side here. And this just showcases how we're going through these processes, how we're getting to very cost effectively to our raw materials, where we can then apply and go into actually producing new materials out of that. One of the big parts that we've seen is everybody is focusing on silver recovery, silicon recovery, and that's very, very important.
To just interrupt, I think if you can maybe switch to the conclusion, it will be perfect.
Perfect. So what we've also done is we've realized that, yes, we can recover silver and we can recover metallic silicon, and there's a very big part of that. But we've actually developed and increased the value of our glass, because 70% of the panel is glass, even sometimes higher amounts. And we were able to, compare to other recycling methods, produce products out of that. And now our glass is valued at about 3 or 4 times as much as other people. And that has a huge impact on where we're going. So I thank you very much. And it's purely by looking at how can we reduce the cost for recycling? And that makes it easier for it to be industrialized. Thank you.
Thank you very much for this very interesting presentation. This ends the part of South Africa. And now we will switch to Australia and how PV recycling is organized in Australia. And first starting with Adrian Piani, who will present to us how PV recycling is done currently in Australia. Adrian, if you can.
Thank you, Marie-Line. It's great to be here. And James, if you could share your screen, we'll share our slides. We'll provide a brief overview of the PV industry recycling in Australia, and then hand over to James Petesic to give a more detailed view of the technology and what's happening. Thanks, James. You go to the next slide. You may have heard Australia is a world leader in solar, a very sunny country, sunny continent, and very aggressively deploying solar. Now, as we speak, 40% of our homes have solar systems on their roofs, and that will increase. You see the graph there, that it's only going to increase and accelerate over time. So we're predicting by the year 2035, there will be 5 million solar panels, which will reach the end of their life per annum. So we have about 12.5 million solar panels are being installed each year. We're saying the average lifespan of our solar systems is around 10 years, and they can last longer, but the reality is that they are or can be pulled off earlier and swapped out. So you can see the graph on the right there really showing that aggressive nature of the increase of solar panels. And the reference there to 1,000 gigawatts of installed solar capacity globally in 2024. Thanks, James. Next slide. So there's some great work done by Dr. Rong Deng, Solar Panel End of Life Management in Australia. You can find that report online. That report estimated that we would have 1 million tonnes of PV waste by 2034. Some of that being the small scale solar panels, i.e. the ones in our roofs, and others at larger scale, bigger than 100 kilowatt systems, which we're seeing deployed across Australia as well. And the total material value from those end-of-life solar panels is projected to surpass $1 billion Australian. As I mentioned, we're not necessarily getting the full technical life of our solar panels, and that third dot point there, the Australian government recently announced financial support to install household batteries. And what we may find is that we will see that program, as people invest in batteries, they might invest in updating their PV system at the same time. And so those panels are coming off earlier than they might have without the batteries being implemented. So at the moment, our existing recycling options are overseas reuse, aluminium recovery only, or full panel recycling. And James will talk to that. Next slide, James. I just wanted to give a bit of an overview of what Australia terms product stewardship, circular economy. It's really our sort of high-level policy view of how we encourage the circular economy and reuse and recycling across many products. As Carsten mentioned, one of the great things we can do is make sure when we design our products for deployment, we design them with the end in mind so that we can encourage their reuse or recycling. And we hope that that will or can occur in the PV industry sector. Notwithstanding, we have so much tonnage of PV systems out there anyway that we have to deal with this, what we have at the moment, which is a wide variety of systems, perhaps not designed as well as they could have been to support recycling at the end. But notwithstanding that, I think as an industry, we should still be looking at our design processes. Thanks, James. And just touching on something from an Australian point of view, it's sort of been touched on by a couple of the speakers previously. From the report that I referenced, these were the kind of actions that were recommended. What we find in Australia, obviously it's a huge country, a big continent. You can see the pictures on the right-hand side showing the deployment of solar systems across the country. Thousands of kilometres between the different installations, which means the transport and logistics is really important. And this study tried to look at where would be the optimal placement of recycling centres to maximise, I guess, economic efficiency in terms of their recycling. But it is a challenge for a place like Australia, which is very large, with population centres widely distributed. So regulatory measures or government policy that support and enable recycling is important in a place like Australia, and that includes collection, accessibility, the ability to get solar panels around Australia into the places they need to get to enable their recycling. Thanks, James. So I'll now hand over to James Petesic, co-founder of PV Industries, to give a practitioner's view of technology in Australia. Thanks, James.
Thanks, Adrian. Hi, everyone. As you can see, that is me. My name is James, and I started PV Industries back in 2018. So, as mentioned, business has been running for over 7 years now. And when I started the business, it was primary goal was to recycle solar panels, stop them going from landfill. It was quickly discovered as we started to operate that we had to obviously face challenges in the reverse logistics, so getting the panels back to us in the central location. Once we got them back to us, what machinery were we going to use? I went out and bought an Italian deframer. I think it was in 2019. It arrived 2 years late and broken. We quickly realized once we started using it after fixing it that it was only able to process about 20% of the panels that were in the market. As one of the previous speakers were talking about, the variation in size was the primary reason that was the case. So we went down the path of inventing our own machinery. Once we did start recycling panels, we were creating products like solar glass, which people had never heard of. So trying to sell a product that no one knows what it is, we had to come up with new end markets to sell these products to, or educate the market as to why they should be buying ours versus another type of glass. And then, as you can see below, we've gotten into the solar panel testing and also lithium-ion battery space, but I'll focus predominantly on panels for the discussion today. So on the screen, you can see a broad level shot of our monofacial or the rooftop recycling line. The way we've broken it down, sort of rooftop and solar farm panels. Rooftop panels are monofacial, meaning they have one single-sided glass. We have developed a deframer and a deglasser. The deframer recovers, as you can imagine, the frames, the junction box and the cable. The deglasser strips off the glass in a sort of very similar fashion to the previous presenter, with the sort of colored, the crushed up glass, super clean. And what we're left with is a 1 millimeter thick flexible solar panel, which is effectively the cells encapsulated by the EVA. We just started to go down the path of accepting panels from solar farms. And whilst people think solar farms have only been around for 5 to 10 years, why are they reaching end of life? Well, the farm itself is not reaching end of life. The panels get damaged during construction. And when you have 1 million solar panels on a farm and the damage rate is 1%, that's still a large volume of solar panels. So we received bifacials and we attempted to deframe and deglass, and we quickly realized that it needed a different approach. One, because the machinery wasn't suitable. The contamination levels were too high. And two, the throughput of our residential line was not meeting the speed at which we were receiving, 3,000 panels, 4,000 panels per day. We couldn't keep up. So we went down the path of developing a utility scale bulk process, which is capable of processing 10 times the volume of what the industry currently achieves. It runs at about 20 tons an hour, and that was designed to receive 3 B doubles in one day, and specifically for bifacial solar panels rather than the monofacials. So just to give you an idea of what the products look like, so above the line, we have the whole frames, the glass and the laminate from the monofacial or the residential line. And below the arrows, we have the shredded aluminium, glass, and what we're calling the EVA sandwich. So once we get to step 3, we will blend up the laminate and EVA sandwich into what we're calling solar metal, which is effectively a powderized solar cell. That will go through a chemical process to extract 99% pure silver and 99% pure copper. So we have today in practice and in place these 2 lines. The third step, the chemical extraction, we've extracted that silver button that you can see in the top right of the screen at lab scale. So we have proven that there's silver in the cells. We've proven that we know how to get it out. And now we're in the process of trying to raise some capital to go out and purchase the chemical extraction line so that we can do that and be one of the first companies in the world to be commercially extracting silver from the solar cell or solar panel. Now, the metals, in terms of the end markets and where do these products go, the metals are pretty straightforward. They all have global commodity prices that are traded, and we can determine the price of aluminium, copper, and silver really easily. And they're when I say fairly easy to get to, the copper cable and the frames are fairly easy. The silver and the copper in the cells, not so much. Where the interesting part becomes with the glass is, again, like the previous speaker mentioned, there's such a variability in the end markets that you can sell your glass to and the prices that you can receive from these end markets. In New South Wales, which is the state that Sydney is in Australia on the East Coast, the construction industry demand over 1 million tons of recycled glass per year to put into things like concrete and asphalt as an aggregate. Now, although this is a relatively low volume, it is an incredible low value rather. It is incredibly high in volume that they need. So it's a great market as volumes increase, like you've seen in every single geography around the world. The graph of installation looks very similar. So there will be an immense demand for solar glass. We've gone down the path of obtaining certification and an exemption from the New South Wales EPA, which is the Environmental Protection Authority, where we've tested the glass to ensure the government that it has no adverse impact to the environment by using it in concrete and asphalt as an aggregate. So there's no excessive amounts of metals that would potentially leach into the environment. The other market that we've activated is a much higher value, but lower volume comparatively to our 1 million tons per year. And that is architectural finishes like manufactured stone benchtops, where we can get a much higher, sort of 3 to 5 times the price of the construction market. However, their demand per year is obviously much less than 1 million tons. At the moment, we are able to sell all of our glass to the higher value architectural finishes application, but it is also very important to maintain the higher volume construction applications active, so that when we do receive and have much larger volumes of glass, that we are able to sell it to those businesses as well. And finally, as a few people have alluded to, the importance of keeping things like aluminium in circulation for as long as possible is super important from an environmental point of view, because creating aluminium from recycled aluminium consumes 90% less energy than when refining aluminium from bauxite. Solar panels are made up of between 75 and 80% glass, depending on if they're monofacial or bifacial. So having a robust market or markets for the glass is super important to ensure that we can achieve high recovery rates. And then finally, if we do not start recovering the silver that is contained within solar panels, by 2050, the solar industry alone will be consuming 90% of the world's silver supply. Thanks very much. And if there are any questions, we'll be here, Adrian and I, to answer them.
Thank you very much for this very clear and accurate presentation, and also on the perspective and the risk we have if we do not recycle. Now, before going to the question part, which may be very brief, I would like to give the floor to Dr. Yogi Goswami, scientist, who will give the perspective on the US point of view and situation on recycling. So, Yogi, if you are here, if you listen to us, I mean, you can start showing your presentation, and we will be very happy to give you the floor.
Okay, thank you very much, Marie and Carsten, for inviting me to speak in this webinar. And welcome everyone from Tampa, Florida. Good morning. I'm going to give you perspective of recycling of PV panels and other components in USA. And by the way, I want to thank all of the panelists before me for excellent presentations, and I've enjoyed listening to the other panelists. As a background, others have already said that, and I'm just repeating it, that there's phenomenal growth of photovoltaic installations in the world and also in USA. The installed capacity in USA is approximately 250 gigawatts right now and growing rapidly. But I have to revise that statement because things are changing very rapidly in USA between the time I made these slides and now things have changed. For example, yesterday the US House of Representatives passed a big beautiful bill that took away all of the federal tax credits for solar panels. And so that act is being signed today by the president, and it's going to go into effect from January 1, 2026. So what I expect is that between now and December 31st, there will be a lot more sales of solar systems than what we expected before. However, from January 26, the sales will drop down dramatically. And at that point, it'll probably be people like me who think about solar for the world, for our climate, who may continue to buy, but others may not buy at that time. So that's an unfortunate development in USA. So as far as recycling is concerned, the publicly available information, if you look into the media and other places, you might think that recycling picture in USA is very optimistic. Reality could be different. I hope I'm wrong. Now, current recycling regulations, the end of life disposal for solar products in USA is governed by the Federal Resource Conservation and Recovery Act, RCRA. And so this act considers a majority of the solar panels as solid waste. In other words, that they could go into landfills. And if the panels have materials that exceed the RCRA threshold for toxic materials, then they are considered hazardous waste. So as far as the federal government is concerned, if you look at it, there's not much about a necessity of recycling. However, the Solar Energy Industries Association in USA is working collaboratively with the regulators to develop implementable regulations. Now, most states, so in USA, states are the ones who really decide what happens over there. And most states have policies on the books. But unfortunately, just very few have implemented those policies for recycling. So, as I said, that the Solar Energy Industries Association has really started the recycling program, and they set up a consortium back in 2016. wait a minute. Okay, so that consortium is made up of photovoltaic developers, distributors, installers, and others that have some relationship to photovoltaics, and also companies that do recycling anyway, not just solar panels, but they do all kinds of recycling. So they founded that group in 2016, and the participants in that group can repair, refurbish, resell, recycle modules, inverters, and all of the other components in a solar system. So what are those companies? So these include 10 companies that are recyclers by their business model. In other words, they recycle anything and everything. And there is one company which is actually a manufacturer of solar panels, which is part of it, and that is First Solar. And you can imagine why First Solar would be a company that would be in recycling right from the beginning, because they manufacture cadmium telluride thin film panels. And so right from the beginning, there were concerns by the environmentalists about end of life of cadmium telluride solar panels. So First Solar, right from the beginning, started looking into recycling of their panels, mainly to put to rest any concerns people may have, so that that would not affect the sales of their panels. So as I mentioned before, current participants include 10 recycling companies and one manufacturer, which is First Solar. Now, it turns out that First Solar is the largest photovoltaic recycler. It's definitely in USA, but I think in the world also. And First Solar's, this is from their program, that it recovers 90% of both bulk, which is glass, and other materials from end-of-life panels. And their recycling capacity is 150 metric tons per day in USA. However, 90% of the panels that are being installed are silicon panels. Okay, so First Solar does not recycle silicon panels. So, in summary, first of all, this is a concern that there is no federal mandate or a formal program for recycling in USA, which concerns me a lot. And so recycling depends on states. And as I said before, most states have policies, but very few have implemented them. It all depends on which government is in power over there as to how important they think circular economy is. So the National Recycling Program, as I said, for PV, was really started by the Solar Energy Industries Association. And that includes mostly companies that are recyclers of other kinds of materials and wastes. And so it was natural for them to say, okay, they could do recycling of photovoltaic panels also. First Solar, as I said before, is a bright spot in the recycling activity. In otherwise not a bright picture that I see right now in USA, because recycling for them will depend on just pure economics. It's not like they worry about the environment and what happens to those materials, but it's as to how does it, how economical it is for them to do recycling of solar panels. Now, my concern about it, a big concern, based on some other things that I've seen happening. For example, every week we put out material that should be recycled outside our lawn so that those recycling companies can take that material. And so that includes all of the materials that could be recycled. But it's really unfortunate to find out that most of those companies simply take that material that should be recycled and ship it to some other parts of the world, to countries where they would take it. They would probably tell these companies, oh, they're recycling. Some of it could actually go into the sea. And so if that starts happening with the solar panels also, that would be unfortunate. So that is my big concern. And so my feeling is that right now, unless things change drastically in USA, but we have a administration right now that for them solar is probably not up high in their priorities. So most of those panels, from what I see right now, might end up in landfills, which is very unfortunate. But I hope I'm wrong. I hope that changes, and people around the country now, looking at how people feel based on the surveys, 80% of the people in USA, they want to see solar panels and other components being recycled. Because they are concerned about the environment, concerned about resources, concerned about materials, and so. But then, it all depends on which governments are ruling which states, and so that's the unfortunate part. I hope that I'm wrong about it. I hope things will change, and that we in USA will be recycling all of our solar panels, recovering materials, not just silver and copper, but all of the other materials also. And therefore, not only help in resource conservation, but also in the environment. So with that, I thank you, and like other panelists, I will be open to any questions.
Thank you very much, Yogi, for your presentation. And I think we all share your hopes, and that recycling will really become something really developed and adopted in all the countries. There are already a couple of questions, but I think other may come. The first one, I think, is really linked of what you said, but also other panelists said. It's about economics of recycling. The question is more, is today recycling economic, or does it need regulation and constraint from regulation to be put in place? I don't know who to answer that, because the answer may be different on the countries and on the national or regional perspective.
Yes, I am not so pessimistic like Yogi was, but thank you very much for your great presentation. The question of whether it's economic or a regulatory process, recycling of PV modules and panels, I think here in Germany it's more an economic question. And of course, a company has to earn money, and they do it by, in this case, by recycling it and selling the components for reuse in new panels or in glasses or in asphalt for the streets or something like that. This would be the best way to go further on in photovoltaic development. Otherwise, I think it's a mess. If you really put it into the sea, it is so spoiled. It's after some time full. No, I hope it's economic reasons.
Yeah, but is it okay if I answer also?
Of course.
Okay, all right. So as I said, that economics will play a big part. I hope that the state governments in USA and the federal government implement certain policies that incentivize recycling, and that way economics becomes positive. But otherwise, as you can see, on the one hand, we are very happy that the price of solar panels has come down drastically. I remember from the time I started working that the solar panels used to be $100 a watt. So only space programs could use them. Now to close to 25 cents a watt. And so that has actually accelerated the deployment of solar PV panels. But at the same time, it makes recycling of those panels, very much dependent on the labor costs and other costs wherever they are being recycled. So this is why I am a bit pessimistic in USA, but I hope that good sense prevails eventually, and we have policies that will help.
Yeah, it's a great pleasure for me to realize that the time we ask for, 1.5 hours, is completely full. There's not so much time for discussion, but I think all panelists gave us such a deep and impressive view of their work, their possibilities at home. And so I think we got a very good overview over our 4 regions in the world, of course, leaving out very strong photovoltaic users like China. But you 3 and me, of course, you answered to my presentation, which I gave on the WEC in Prague, and there was not so much questions from others. And I thank you from my side as the chair of the Solar Group very much for your interest and for your very interesting presentations. It was a great help, I think, for the whole photovoltaic economy and society to hear all of you. Thank you very much.
Thank you very much, Carsten, too, for organizing this webinar, for putting all the panelists, the wonderful panelists, on different regions. And thank you very much also for the panelists who are today members of the Solar Task Group. I have a message to all of you who are here, member of one of the engineering organization of WFEO. If you want to contribute to the work WFEO Committee on Energy is doing, and in particular in Solar Task Group, chaired by Carsten, you are more than happy to join. For that, we will send you all the details, but you can be part of that task group and showing different and completing the other perspective. And second element, there will be a sharing of the webinar, but also the PowerPoint, the presentation to all of you. So we will be more than happy to continue the discussion. And for those who have raised some question we have no time to answer, please feel free to ask us directly, and we will be more than happy to answer them, because it's important to have that kind of open discussion.
Yeah.
showing that there are not only issues but also solutions. And this is what I particularly appreciate on the webinar today, that we see the issue, the challenge, but also some technical perspective. And the last point, WFEO will organize in Shanghai in October the Global Engineering Conference, and there will be a dedicated session to clean energy with some participants from the Committee on Energy of WFEO. For those who are able to attend, we will be more than happy to invite you to participate to that forum and also to the Committee on Energy meeting, which will be an open committee meeting on that specific time. So thank you very much to all of you. Thank you very much to all the panelists for your great work, and a special thanks to Carsten Ahrens, the chair of the TOLA task group, for this amazing work and wonderfully organized webinar. Thank you very much, Carsten.
Thank you.
It was a pleasure, and I wish you a good morning, a good night, and a normal day, like we have it in Germany or in France now.
Yes.
Very early or very late in the daytime. So thank you till the next time. I do hope we do it another time. Maybe.
I'm sure.
Bye-bye.
Bye.
Thank you, Carsten.
Thank you.
Bye.
Bye.